This is a video overview of the Blockade Chrome extension. Blockade brings antivirus-like capabilities to users who run the Chrome browser by inspecting outgoing web requests for websites or materials that may be deemed malicious by analysts. A little bit more about how this works specifically. Blockade has a team of volunteer analysts that are constantly contributing malicious indicators of compromise into a cloud node. After installing the Blockade Chrome extension, these indicators are then passed down to each individual browser and stored inside of local storage. Before any web request is able to go out and online, it's checked to see if there's a match to what's in the local storage. If there is a match, that website's blocked and the user's notified. Depending on the configuration, users can send event data back to Blockade and complete an analyst feedback loop. Now, if we wanted to install the Blockade Chrome extension, we could do so simply by clicking the Add to Chrome button. This gives us a prompt where we can add the extension, and then it's going to redirect us to its configuration. Most of the default configurations don't need to be changed, but the one that is most important is our server URL. This is the place where we're going to get the indicators of compromise. Clicking the Save button is actually going to kick off a process to update and prime our actual local storage with the indicators of compromise. After clicking Save, we'll see that our configuration was saved successfully. We can close it, and then once it's completed, we'll get a notification. We can see here up in the top right-hand corner that we have an indicator database update and that we have one item saved to local storage. For demo purposes, this one item is test.blockade.io. In reality, when you're actually using the Blockade Chrome extension, this could be hundreds or thousands or tens of thousands of indicators pressed down. One of the nice things about the Blockade Chrome extension is that the user does not have to do anything. These are automatically updated as the analysts input them into our cloud node. Now, if we wanted to test this out, we have two different ways. The first is testing out a situation where test.blockade.io is loaded via JavaScript source element inside of a page. It may not be as obvious that something malicious is going on. We can visit that by going to Blockade and then the demo page. You can see here that the page renders, but in the top right-hand corner, we have this notification telling us that malicious traffic was blocked. We can see that test.blockade.io tried to load via a GET request using a script source element. What's nice about Blockade is that it has the capacity to look not only at script source elements, but any request that actually goes out of the browser, HTTP or HTTPS. For cases where it's not always as obvious like this, it's great to have that notification pop up and let you know that something malicious was detected. For the more obvious case of browsing directly to the website, we'll be presented with an actual page. We can see here again, up in the top right-hand corner, a notification takes place letting us know that the website was blocked. And now we're presented with a red warning screen letting us know that a suspicious site was reported. At this point, as an end user, I have two different options. I can be taken away, which will redirect me back to my previous page or an About blank screen, or I can accept the risk and temporarily whitelist the item. For most cases, we're going to recommend taking the user away. But in rare cases where you actually have to whitelist the individual item that we've blocked, you can simply click the URL and temporarily whitelist it. We can see here this is the content of the page. What's nice about Blockade is that it's completely transparent to the user. After the first configuration, nothing else needs to be done, and the user can simply continue browsing and hopefully never seeing red warning screens. In the event that they do, there's a team of analysts that are processing the information and regularly updating this in order to combat these attacks.